Welcome back to the Ready for Merge show, hosted by yours truly, Christine D. Kim. Today's show is the last Ready for Merge show of 2025. This show is going to be going on a 2-week break over the holidays and returning uh, back on during the first week of January. Um, and so, this is going to be the last kind of like bi-weekly brief, the last update that I give on Bitcoin and Ethereum protocol development for this year. And then I'll be back in 2026 with more updates and with more guest episodes featuring both Bitcoin and Ethereum developers. Fingers crossed on the Bitcoin developers. I'm making progress on that. Um, and this year, or this episode, when I was thinking about kind of what I wanted to talk about, I normally talk about the biggest code changes and merges that have happened over the last 2 weeks in Bitcoin and Ethereum protocol development. I figured for this show, since it's the last show of 2025, I would actually talk about the biggest, most influential code changes of the year. So taking kind of like a year in review for what were the most important changes in both the Bitcoin and Ethereum protocols, just highlighting the the big numbers, the big code merges. Um, there was quite a few code merges on the Ethereum side that I want to talk about on today's show, and then a few that I think were pretty important on the Bitcoin side this year. So thank you guys all for joining for another episode. If you're joining from the live stream, feel free to ask any questions in the chat as I go. If you have any questions about the code merges that I'm talking about. But without further ado, let's get into it by starting with the Ethereum code merges first. For Ethereum, when I look back on the year of 2025, there were the two biggest like upgrades, Pectra and Fusaka. These upgrades were backwards and compatible network-wide upgrades. The largest upgrades that Ethereum has done, that Ethereum developers have been able to pull off by the number of EIPs, Ethereum Improvement Proposals. Pectra and Fusaka were both about 12. They contained about 12 different features, 12 different code changes. So put together, that's like 24. That's the most Ethereum developers have ever shipped in any year. So this year has been busy. And when I thought about, all of these code changes, which of these EIPs do I think were the most influential is pretty hard to choose because they were all influential in their own respective ways and targeted different stakeholders in the Ethereum ecosystem. I came down to basically the layer one and layer two scaling improvements that happened throughout the year as being the two most influential features of and like outputs of Ethereum protocol development this year. So on the layer one scaling side, Ethereum developers from January to December of this year have basically doubled Ethereum transaction throughput. So the size of Ethereum blocks, how many transactions Ethereum can process at any given moment, has essentially doubled. The block gas limit has increased from 30 million gas to 60 million gas over the course of 12 months, which is a pretty significant, I think, upgrade. These code changes weren't code changes that required activation via a hard fork, via a network-wide upgrade. They were kind of incremental increases to scaling that developers were able to implement over the course of 12 months through changing the default setting of client software and also through just communicating to the Ethereum ecosystem, particularly Ethereum validator node operators, that they can indeed safely increase the block gas limit, because that parameter is actually voted on and determined by block producers, by validators on Ethereum rather than Ethereum core developers. But it is quite often that Ethereum core developers are really the ones to initiate these block gas limit increases, because of course, if you increase the block size too quickly, then there may be node operators that there may be like hardware and computers that are connecting to Ethereum, but just can't handle the increased throughput. So Ethereum developers over the last 12 months have done a bunch of testing and benchmarking, and Nethermind, one of the major Ethereum execution layer clients, they recently put out a blog post talking about just the improvements that developers have made over this past 12 months in being able to test out block gas limit increases and just really make sure that Ethereum is scaling up to the maximum possible limits of what nodes, Ethereum nodes, and its hardware can possibly handle. And given optimizations in clients, given various features that have gone live through hard forks, the two hard forks that I mentioned at the earlier, Pectra and Fusaka, there has been room for Ethereum developers to say, okay, like we can safely increase the throughput of Ethereum. Here's what we should, the new parameter, the new number that we should try and reach for the block gas limit. So yeah, I got to say, I think the most impactful changes have been these block gas limit increases because they impact all stakeholders of Ethereum. Suddenly, the protocol can process double the amount of transactions. There's double the amount of block space for end user transactions to be included. So that's the first one, the block gas limit increases. And then I want to highlight also the layer two scaling improvements that happened on Ethereum over the past 12 months. This also has been pretty significant and monumental. Ethereum developers have been able to effectively triple, more than triple, the transaction throughput for blob transactions. It's the part of the Ethereum blob that stores ephemeral data. This is part of the Ethereum block that is specifically designed for storing arbitrary data from layer two rollups. So this is all about scaling the number of protocols that are built on top of Ethereum and kind of bundle and batch together end user transactions at a more efficient and cost effective way, and they commit all the data from end users into on Ethereum for data availability. And for the dedicated block space that has its own fee market and has its own kind of dedicated use for arbitrary data for specifically use for layer twos, that the debut of that type of transaction, blob transactions is what they're called, that debuted in 2024, and it started off with just a very small kind of it started off with a capacity that was quite small. Only about 3 blob transactions per block could be included. Well, that was the target that the protocol was trying to set via these dynamic changes in the pricing of blob transactions. So anytime a blob contained more than 3 blob transactions, the price of blob transactions would increase exponentially over consecutive blocks if the target of 3 blob transactions continued to not be being met or wasn't if there were a lot of consecutive blocks where the number of blob transactions exceeded the target of 3, then the price of blob transactions would start to increase exponentially, and also vice versa. If there's consecutive blocks where the pricing for blob transactions falls below the target of 3, then the fee for blob transactions would decrease. This is how the dynamic fee market of not just blob transactions work, but also the regular Ethereum transactions. This was a bit of a tangent explaining the fee dynamics for blobs, but I say it to kind of highlight that the target for blob transactions has gone from 3 in the beginning of the year now to 10 blob transactions, which is an over tripling of of blob transaction throughput. It's just a lot more scale, a lot more room for these types of transactions. And come January, in the first week of January, there is an automatic blob capacity increase already scheduled within Ethereum, across Ethereum nodes, where the blob target is going to increase from a target of 10 to 14. So including that second blob parameter only increase, developers have, yeah, more than quadrupled, or I guess that's like a 5x increase, almost a 5x increase in block capacity that developers have worked on and are confident, have felt confident about shipping over the course of the last 12 months. And on the latest Ethereum developer call, the one that they had on Monday, which is the second last Ethereum developer call of the year, the last one will be held this Thursday, tomorrow, because I'm recording this podcast on Wednesday, December the 17th. Developers talked about what needs to happen for Ethereum developers to continue increasing the layer one scaling, so further increases the block gas limit beyond 60 million gas. And they also talked about another blob capacity increase, another blob parameter only hard fork, their third one, for activation after seeing how the network handles the second blob parameter only hard fork BPO2 come January 7th. So there's quite a few more scaling improvements that Ethereum developers are looking ahead to, but when I look back on all of the features and the code changes that have happened on Ethereum over the last 12 months, definitely the results of all those features and kind of the culmination of a lot of Ethereum developers' efforts have culminated in these scaling improvements to layer one, just regular Ethereum transactions and usage, and then also specialized usage of the Ethereum protocol for data availability for committing arbitrary data to the blockchain. And in both regards, Ethereum developers have achieved, doubled the scale, and for blob capacity have successfully been able to ship upgrades that will increase blob capacity by close to 5x. And while these scaling improvements don't make Ethereum as a blockchain as scalable as, say, its competitors, alternative layer one. So Ethereum is still not as fast or as cheap as, say, alternative layer one blockchains like Solana, or offers the same kind of capacity for data availability as alternative layer one blockchains like Celestia. These improvements, these scaling improvements, are ones that illustrate to Ethereum stakeholders that Ethereum is, as a protocol, is evolving and developing so that it can be and compete alongside these alternative layer ones in terms of scale, in terms of being able to compete with Solana and Celestia in terms of data availability capacity, and also just layer one blockchain throughput, transaction throughput. And I think it's just kind of like a show or a sign of good faith that the Ethereum protocol is not ossifying. It is continuing to try and evolve towards the direction of being faster and cheaper, like these other alternative layer one blockchains have also been working on. I mean, these alternative blockchains were kind of built from the ground up to be highly scalable, fast and cheap, or highly specialized for the use of data availability. Whereas Ethereum as a blockchain in 2015, when it first launched, it was the only general purpose blockchain of its kind, the first of its kind. And in many ways, learnings about scaling blockchains and also taking advantage of kind of the more performant hardware and bandwidth capabilities of nodes around the world. This is something that Ethereum is a bit slower to adopt and react to, especially because, again, the protocol wasn't designed or built for this type of scale in 2015. Um, this year in 2025, I think Ethereum developers have really kind of shown that Ethereum is not ossifying. It is a protocol that is trying to compete in the same regards with alternative layer ones in terms of scale and wants to scale for both in terms of the layer one and the layer two protocol. And so, a big kind of question heading into 2026, as we look ahead to some of these further layer one and layer two scaling improvements, is can Ethereum developers keep up this pace of development? Can Ethereum developers achieve kind of the same level of success and results when it comes to continuing to, as I mentioned, increase block capacity through further BPO forks and through further block gas limit increases. There, as I've kind of covered on this show over the last couple months since I launched Ready for Merge, there has been tension between the pace of Ethereum development and also the risks that code changes can often bring, especially code changes that increase the scale of Ethereum to network safety and also network decentralization. Um, as I kind of touched on, when Ethereum developers increase the capacity of the protocol, they have to really make sure that all node operators, or at least the vast majority of them, have the hardware and have the operations to still be able to operate and still be able to connect to Ethereum and validate the Ethereum blockchain. Because if they're not able to, then they disconnect from the network and Ethereum loses a certain amount of decentralization, a certain amount of node operators that are helping to secure Ethereum. So yeah, a big question is can Ethereum developers continue to keep up the pace of development that we've seen in 2025 and 2026, um, and do so in the same way where they're with Pectra and Fusaka, there hasn't been major drops or major concerns when it comes to network safety or decentralization. But are these risks that perhaps might rear kind of its ugly head in 2026 if this pace of development continues? Another risk when it comes to increasing speed of development is concerns and risks of centralization when it comes to governance. When decisions have to be made more quickly about what code changes to include in an upgrade, there might be more contention. There might be a smaller group of stakeholders that are needed to make faster governance decisions. Can Ethereum continue to upgrade and evolve as a protocol as quickly as it did in 2025 and 2026? Even when the stakeholder base and the number of governance participants increases? Or does something have to give where perhaps Ethereum developers in the governance process actually has to centralize more to a smaller number of stakeholders for the pace of a development and for the scaling improvements that developers want to achieve in 2026 for those to continue to happen. So those are some kind of important considerations and questions that I'm asking as we head into the new year for Ethereum development. But I will say that in terms of these concerns around the risks, I think Ethereum developers have really shown and proven in 2025 that they can make these scaling improvements at the pace that they're making. Yeah, in such a way where the protocol hasn't responded negatively. There hasn't been um, major network outages or there hasn't been any significant bugs discovered on Ethereum since they've implemented these pretty big hard forks, Pectra and Fusaka, and also in parallel implemented these layer one and layer two scaling improvements. So truly, I think it's been a very kind of significant and monumental year for Ethereum in terms of the layer one and layer two scaling improvements that have happened. And the big question now is, again, really in 2026, how sustainable is this pace of development? So yes, those are what I would say the highlights and the look ahead for Ethereum protocol development. Let's start talking about Bitcoin, the highlights of Bitcoin protocol development, starting Bitcoin protocol developments of 2025. I will say on the Bitcoin side, I am a little bit biased in the code changes and the features that I've chosen as the most influential for 2025 on Bitcoin protocol development because I really started covering Bitcoin protocol development in earnest in the second half of 2025. So Ethereum Core development, Ethereum Core as a software has come out with two major releases this year. This is normally their pace of development. It's two major software releases per year. And I wasn't quite focused, locked in for the V29 version of Bitcoin Core. I really started to cover Bitcoin Core development closely when Bitcoin developers were preparing for Bitcoin Core V30. Um, that being said, though, even when I look back on the discussions for Bitcoin Core V29, I will say Bitcoin V30 was the more controversial one, and I would say was the more memorable Bitcoin Core major release of 2025, particularly because of PR 32406, the uncapping of the data carrier size by default. This code change, this code merge, basically lifted the 80 byte limit on opportune data such that Bitcoin nodes will relay and will send around transactions containing a larger amount of arbitrary data attached to that transaction. So, as I kind of mentioned around this PR in a prior Ready for Merge episode, which I will link to in the show notes if you're interested in learning more about this PR, um, this PR is not a change to the consensus rules of Ethereum of Bitcoin, I should say. This is a code change primarily that just simply changes the policies around unconfirmed transactions, around what transactions are relayed between Bitcoin nodes um, for inclusion in the mempool in the list or log of unconfirmed Bitcoin transactions. And before this PR, there was a limit on the amount of arbitrary data that is contained in this field, in the opportune data field, of 80 bytes. But as Bitcoin developers have noticed that already there's been some fragmentation in mempool policy with the rise of a narrative around Bitcoin, of programmability on Bitcoin, there's been more of a push to change that default setting. And this is a default setting that certain nodes, that node operators themselves can change if they wanted to. Um, Bitcoin Core developers for a variety of reasons, more so related to the cohesiveness of the Ethereum of the Bitcoin mempool. I keep saying Ethereum because we've been talking about Ethereum for the first half of the show, but for Bitcoin, the cohesiveness of Bitcoin's mempool, and when it comes to various techniques around including Bitcoin transactions in Bitcoin blocks and kind of ensuring that Bitcoin nodes are as performant as possible. Bitcoin Core developers have included this PR into the V30 release, but that created a bunch of controversy, especially because of proponents in the Bitcoin community that were very strongly against any code changes that would encourage or be seen as kind of like a stamp of approval for using the Bitcoin protocol for non-monetary use cases, for, say, creating non-fungible tokens, for creating ordinals, for basically committing any types of arbitrary data on Bitcoin. This is a use case that certain proponents of the Bitcoin community do not think are not appropriate use cases for the Bitcoin protocol. And so this PR was quite controversial. Because of this PR, there was an alternative Bitcoin protocol, or I should say, an alternative version of the Bitcoin protocol, a client version of Bitcoin that started to gain more traction, called Bitcoin Knots. And there was also quite a bit of controversy around Bitcoin Core as just a developer group. Um, to what extent is Bitcoin Core stewarding the Bitcoin protocol well? As the most widely adopted and used software to connect to Bitcoin and to validate the Bitcoin blockchain, is the institution that is Bitcoin Core reliable and trustworthy? And are they stewarding the protocol well? There was quite a bit of controversy and just, I would say, a lot of toxicity coming out of various stakeholders of the Bitcoin community over this PR and over this code change. Ultimately, the merge did happen. This PR is part of Bitcoin Core V30, and last I checked, about 14% of publicly identifiable Bitcoin nodes have adopted this version. It's the most widely adopted Bitcoin client out there, at an adoption rate of 14%. But I think because of just the community divide and the community kind of like controversy and discussion that happened around not just this PR in particular, but just more broadly Bitcoin Core's stewardship of the Bitcoin protocol. I would say it was one of the most influential and impactful code merges of 2025 on the Bitcoin protocol development side. A second PR that I want to highlight that came out, that happened more recently is PR 30595. I talked about this PR a couple of shows ago. I'll also link to that show in link to that episode in the show notes of today's episode, for any listeners that want to learn more about this PR. But very quickly and at a high level, this PR introduces a new API, the first API of its kind that will allow other builders and protocols and software to directly interact with Bitcoin's core consensus logic. So all of the rules that are necessary for validating Bitcoin blocks and Bitcoin transactions, these are the elements of the Bitcoin protocol that um, have been separated out into a separate API from all of the kind of other optional um, aspects and characteristics, or aspects and parameters, I should say, of the Bitcoin Core software client. Um, this is a pretty important initiative because as the majority client, as the client and the software that everyone uses for to connect to Bitcoin, the Bitcoin protocol, um, it's very murky to know kind of what aspects of the software that I'm running from Bitcoin Core is essential to connect to Bitcoin and which components of the software are not essential for connecting and validating the Bitcoin blockchain. As I mentioned, the PR we just talked about, 32406, that's a great example of a PR that is specific to Bitcoin Core software, but not an essential code change or feature that is essential to defining the Bitcoin protocol. And so this API is an API that the C header API, this PR, is an API that allows stakeholders to be able to interact and identify and verify the consensus part of Bitcoin Core, which is essentially the kernel. It is the Bitcoin protocol. And that kind of separation, the separation of Bitcoin Core software from the Bitcoin protocol, I think is really important, especially as Bitcoin looks ahead to perhaps more client diversity in the future. It will make it easier for new groups of developers to perhaps create alternative implementations of the Bitcoin protocol that is compatible with Bitcoin Core, that gives Bitcoin node operators more choice and more freedom when it comes to choosing what software they want to use to connect and validate the Bitcoin blockchain. And truly, this is a PR that developers are continuing to work on. They're continuing to refine the test cases for it. It is by no means kind of like an initiative that is over. It's work that I hope continues to see a lot more focus and attention in 2026. But just launch of the API itself and just like the specifications for the API itself, I think was a major milestone and step for Bitcoin protocol development. One thing I wanted to note though about some of these code changes that I'm talking about, especially PR 30595, this is not a PR that has been included or has seen a lot of adoption among nodes on Bitcoin. So as I mentioned, for Bitcoin V30, which does include PR 32406, the first one that I mentioned, only about 14% of publicly identifiable Bitcoin nodes actually use this feature, have been impacted by this feature. For the second PR, it was merged into after V30, so it's most likely to be included in the V31 Bitcoin Core release. But because these releases, these software releases for Bitcoin Core, are not containing consensus-breaking code changes, the adoption for these code changes happen extremely gradually. Just to put things into a bit of perspective, Taproot, which was um, the most recent network-wide upgrade on Bitcoin that introduced a backwards compatible code change, improving privacy and scalability for Bitcoin. That upgrade went live in 2021, and adoption for Taproot type transactions still hovers at about 20%. Um, so the impact of these features and these new code changes for Bitcoin protocol development is quite a ways smaller, and the impact footprint is quite smaller than the code changes and features that I was talking about on the Ethereum protocol development side. On Ethereum, these are consensus breaking code changes, or some of them are consensus code breaking changes that all nodes, 100, the vast majority of Ethereum nodes are adopting and implementing so that they don't um, get booted off of the Ethereum protocol, so that they continue to validate the same Ethereum blockchain that all the other nodes on for Ethereum nodes are validating to. Um, and so when I think about oftentimes when I think about Bitcoin protocol development, the impact of these code changes and these code merges are a bit different. But it's not to say that these code merges and the protocol development of Bitcoin is less important to Bitcoin stakeholders than Ethereum protocol code changes are to Ethereum stakeholders. A lot of people have told me, especially since I started covering Bitcoin core development, that Bitcoin core development doesn't really matter, that the protocol these kinds of evolutions and code merges on the Bitcoin core side, it's not as important as what I cover on Ethereum, because even if these code changes aren't implemented or are not adopted, the Bitcoin protocol continues to run. These are all backwards compatible code changes. And as I mentioned with some of the statistics, it's true, there's not really a ton of adoption for these features straight off the bat. Even when they do introduce improvements for certain Bitcoin stakeholders. But to those kind of comments, I would highlight just a few reasons for why Bitcoin protocol development still matters to all stakeholders. First of all, these are code changes and features that may impact and help businesses building on top of Bitcoin. I believe on the last I think 2 weeks ago, on one of these biweekly briefs, I was sharing about a PR merge related to the cluster mempool project, and how the cluster mempool initiative will help Bitcoin miners build more profitable blocks. These are features and code changes that may impact particular stakeholder groups, for better or for worse. And so it's worth staying up to date with what protocol changes are being implemented into Bitcoin for that reason, even if some of these code changes are not ones that will break or will cause businesses to um, lose connection or have to stop validating the Bitcoin blockchain. There's still features that could be impactful to your business or whatever business is being built on Bitcoin in other ways. Perhaps when it comes for the cluster mempool examples for miners to build more valuable blocks. Also, as I was talking about with the uncapping of the data carrier size, I think there was quite a bit of controversy around one of these features around Bitcoin Core V30 because it was influencing and perhaps shaping the Bitcoin narrative and Bitcoin's value towards a direction where non-financial use cases are an appropriate use case for Bitcoin that some community members in the Bitcoin stakeholders in the Bitcoin community don't agree with. So to know to know it's not enough to just know that the Bitcoin consensus protocol works in a particular way. There's various ways in which the Bitcoin protocol can be used, and to kind of and to know that even small code changes, the ones that are backwards compatible, they influence how users can use Bitcoin protocol. It could open up new use cases for Bitcoin for the Bitcoin protocol that didn't exist before. And so for that end, I think Bitcoin protocol development is still worthwhile to track, even if perhaps the adoption of these features are not as they're not mandatory features for node operators to adopt like it is on the Ethereum side. And then finally, one of the things I want to mention around Bitcoin protocol development, and one of the reasons why I think it's important to continue tracking in 2026, is that there are indeed features and code changes that need to be implemented by the vast majority of Bitcoin node operators in the future of Bitcoin. So one of them is the quantum signature migration. If Bitcoin users do not migrate to quantum secure signatures and address, is it address? Yeah, address types, then there is the potential that in a world where quantum computers exist and they're commercialized, that the funds held in these addresses will no longer be secure. That a quantum computer could hack the funds held in these addresses. So a migration of the vast majority of Bitcoin stakeholders from non-quantum secure signatures to quantum secure signatures. This is a type of code change that is actually required. Is a code change that the vast majority of stakeholders will have to care about. Even though the most frequently the types of code changes I talk about on this show are backwards compatible and are don't they're not time sensitive in terms of requiring to adopt them. And there's of course backwards compatible ways to developers are discussing backwards compatible ways to introduce quantum security to the Bitcoin protocol. It's just the impact of these code changes. They have time sensitivity to them, which for something like Taproot, for something like changes in the mempool policy, these are not time sensitive code changes that Bitcoin stakeholders need to act on immediately. And secondly, there's the end time overflow problem. This is a problem that is going to that Bitcoin stakeholders in the community will truly have to reckon with at the latest by the year 2106. The Bitcoin block timestamps use a 32-bit counter, and in the future, decades into the future, the value for the 32-bit counter, it's going to exceed. There's going to be an overflow. There's going to the max allowable value for 32-bit. This 32-bit counter will be exceeded. So developers do need to transition over to a larger counter, perhaps 64 bits for Bitcoin block timestamps. And the most straightforward proposal that developers have talked about recently for addressing the end time overflow issue is a hard fork. It is a backwards incompatible upgrade to update the Bitcoin block timestamp, which is a very minor change to the Bitcoin protocol, but it is an example of a code change that all stakeholders, or at least the vast majority of stakeholders, will need to adopt to continue to validate the same Bitcoin blocks. So another kind of time-sensitive code change and feature that again are not these types of code changes are not frequent in the Bitcoin protocol development Bitcoin protocol development, but they do exist. And there will come a time when some of these code merges have time sensitivity to them that Bitcoin stakeholders need to act on. So for all those reasons, I highlight that Bitcoin protocol development is still quite important for anyone that is invested in Bitcoin via either the Bitcoin asset or simply as a business or an institution that's building on top of Bitcoin in any way, has resources, has spent time, interest, is part of the Bitcoin ecosystem in any way. How the Bitcoin protocol is evolving still matters, either for the way these features could impact or help your business, either for the way that it shapes the narrative around the Bitcoin protocol and the value of the Bitcoin protocol, or in these very kind of like unique use cases where the protocol changes do actually have to be acted on in a timely manner. So, yes, those I would say are my thoughts on looking back and looking ahead for Bitcoin protocol development. I don't know if this is probably my longest biweekly brief episode. I had a lot to say because it's been such a big year for these protocols for both Bitcoin and Ethereum development. And I'd say it's been a pretty big year for me too when it comes to covering these protocols, how I cover them, on what platform I cover them. It's just been a really kind of, yeah, major year for me, and I'm so grateful for all of you, my listeners, for joining this show, for joining for these episodes. I hope that they have helped you keep up to date about what is happening with the Bitcoin and the Ethereum, what's happening with Bitcoin and Ethereum protocol development. I thank you so much for the support in listening and watching the show. Again, this is going to be the last episode for this year, for 2025. I'm going to go on like a bit of a holiday break for the next 2 weeks, but I'll be back with a new biweekly brief the first week of January. Um, so, yes, please do, if you have any questions or want to catch up on some of the major code changes that I discussed on today's show, be it with Ethereum or Bitcoin, a link to particular episodes where I go deeper into depth. So check out the show notes if you want any more information on what was discussed on the show. Please be sure to like, subscribe, share this episode if you think it'll be if you liked it, and if you think it'll be useful for perhaps anyone else in your community. But yeah, other than that, I will talk to you guys all again in the new year in 2026. You are all officially caught up on what has been merged and what's ready for merge in Bitcoin and Ethereum protocol development. Thank you again for listening, and happy holidays, everyone. Bye.